In 2019, the US government slammed the brakes on China's technological rise by banning key chip and software exports.
The Trump administration has told American software companies to immediately stop selling software used to design semiconductors to China.
This was the beginning of the tech war that would shake the global semiconductor industry. Huawei, one of China's biggest tech companies, was suddenly cut off from the advanced processors it relied on. No more Qualcomm chips for its phones, no more Intel CPUs for its laptops, and even Nvidia and AMD were restricted from supplying Huawei with GPUs and data center hardware. At that moment, many thought China's tech growth would come to a halt. But something unexpected happened. Instead of collapsing, China started building. This is the story of China's silicon breakthrough. How a country once dependent on American and Western semiconductors is now rising with its own chip designs, fabrication capabilities, and AI processing hardware. This is China's life after Nvidia and Intel, and it's one of the most important shifts in modern technology. The initial push came when Huawei was placed on the US Entity List in 2019. This move blocked American companies from doing business with Huawei without government approval. It wasn't just smartphones that were affected. Huawei's access to core computing infrastructure, cloud chips, even Android services was suddenly severed. Washington's strategy was clear: control the flow of semiconductors to slow down China's technological growth. But Beijing did not wait. It responded by going all in on chip independence. Huawei's in-house chip division, HiSilicon, began working round the clock to design processors without US components. In 2023, they shocked the world by launching the Kirin 9000S, a 7nm chip made entirely with domestic technology. It was manufactured by SMIC, China's top semiconductor foundry, without access to advanced EU lithography tools that were also blocked by US restrictions. This achievement was seen as nearly impossible just a year earlier, and yet Huawei pulled it off, proving they could bring 5G smartphones back to market without foreign suppliers. Beyond mobile chips, China's entire semiconductor ecosystem began to evolve. Companies like Loongson and Zhongxing started producing x86 alternative CPUs. Loongson in particular developed its own instructions set architecture called LoongArch to reduce reliance on Western technology like Intel's or AMD patents. While these processors are not yet competing with Apple's M series or Intel's top-end CPUs, they are steadily improving, now reaching performance level close to Intel's 10th Gen Core i3 processors. For artificial intelligence, Huawei developed Ascend series of chips, while other companies like Byron, Cambricon, and Alibaba's T had begun building dedicated AI processors to replace Nvidia's powerful GPUs. These are being used in Chinese data centers for cloud services, model training, and inference workloads. A critical move now that China is largely locked out Nvidia's latest H100 and A100 GPUs. To support this effort, the Chinese government invested heavily in every stage of chip production, from EDA tools used to design semiconductors to chip design, lithography, packaging, and talent development. China started reconstructing its chip supply chain from scratch. A massive $47 billion national semiconductor fund was created to back hundreds of Chinese chip startups and fabs. Educational institutions were retooled to train semiconductor engineers at scale. Despite being cut off from the global tech pipeline, China found a way to restart its own engine. So how good are China's chips today? The truth is they are still behind the most advanced processors made by TSMC's, Intel, and Samsung. But they are improving quickly. The Kirin's 9000S built under sanctions proves that China can produce 7nm class chip domestically. Loongson 3A6000 shows that desktop CPUs, even without x86 licensing, are possible. And Byron's AI accelerators are beginning to support large language models and cloud workloads inside Chinese borders. What matters most isn't whether these chips are better right now. It's that that China now has alternatives. If Nvidia or Intel completely pull out, China won't shut down. It will keep running, and that changes everything. This shift has major global implications. If China successfully builds an entire chip ecosystem from mobile processors to AI GPUs to servers, the power of US sanctions begins to fade. American companies like Nvidia, Qualcomm, Intel, and AMD could lose billions in future revenue. More importantly, we may see the tech world divide into two parallel systems, one led by the US and its allies, and the other by China and the countries that follows its digital blueprint. At the center of this movement is Huawei, once seen as a hardware company, now emerging as a symbol of resilience, not just surviving sanctions, but innovating under pressure. The story of China's silicon breakthrough isn't just about chips. It's about geopolitics, data control, AI dominance, and economic independence. And it's only just beginning. The question now is not, can China build its own chips? The real question is how fast they can catch up, and can anyone stop them? This chip war is far from over. In fact, it's only getting started.